Okay, so we will start with solving problem on question 5.12. So question 5.12. Okay, and so as a part of this problem, we have to do the Fourier transform and use the modulation property to find Fourier transform for another signal. Okay, so let's down problem first. So consider the cosine pulse x of t equal to 1 plus cos phi . Okay, so this is my problem. And part A says that carefully plot T. Okay. Now then part 2 says find the Fourier. My touch screen is not really good, my laptop. So basically my fist is also touching the screen and it's behaving something awkwardly. So that's why you see on the screen jumps. But I will try my best. P of t equal to u of t plus minus u of t minus. Okay, so this is one pulse, and then the third part is use the definition of the pulse P of t and the modulation property in the Fourier transform xt in terms of v omega equal to Fourier transform of. Okay, so this is what we have, and in order to plot, we will use the MATLAB to show you how to plot it. Okay, so let's create a new script. Okay, and then save is at paste cosine.m. Okay, and so first we define the time vector. So let's see t equal to say minus, say I start with like 5. Okay, and then each of the time vector time points is separated by 0.001. Okay, and then my x is 1 plus cos phi multiplied by t. Okay, then multiplied by heavy side. So heavy side is your u function in MATLAB. Heavy side t also dot star, because we want to have an element wise multiplication, minus heavy side t of -1. Okay, and then figure 1 f of, and then plot t x width t, then grid on. Okay, then we can put x label as time. Okay, and y label as x of t. Okay, let's save it and then run. Okay, it did go. So I'm not sure why it didn't execute, but okay. We type it here and then let it execute. Just taking a little bit longer than expected. It looks like my system is slow. Window. Okay, I'll let it run. But in the meantime, maybe my system is overloading. But okay, I can show you in the meantime that we have this one node. Okay, one node is here. So how will it look like? Is that when you will be plotting, it will look like this. Okay. Two. Okay. So this will look like this. Now, point number 2. So first we need to see how does your ut plus minus u is what u plus 1 minus ut minus 1 looks like. Okay. So okay. Okay, so I need to restart. So in the meantime, let's see the problem again. this one, how will you plot it? It's better to plot to understand what does it look like. So like this, we have ut plus 1, so it will be shifted towards the left by 1 unit. This is your um, minus 1. Okay, and it will look like this. Ut minus 1, ut minus 1 will look like your something like this. Okay, but and so now in that case, these will be basically subtracted. So you are only left with this portion only. So this portion, um, this portion is your u plus v plus 1 ut minus 1. Okay, that's what it will look like. This, this is what it will look like. And now we can consider the Laplace transform of this. So here S equal to it will be pure T. And then okay, so this is Laplace transform. And if you see the Laplace transform, so we need to use the two properties in that case. The one, one property, that is the time shifting property. So if the if the time domain signal is time shifted by alpha unit, then you will have an exponential e to the power minus alpha s term in Laplace domain. And so the Laplace transform of u of t is 1 by s, and so the Laplace transform of ut plus 1 will be e to the power s divided by s. And so we will be writing like this, e to the power s divided by s, and this one is in the other direction, e to the power minus s divided by s. Okay, and so p of omega will be s equal to j omega equal to e to the power you like that. Now we multiply and divide by 2. So what you will see is that we have e to the power j omega minus j. And so from the Euler's identity, um, from Euler's identity, know that e to the power e to the power I theta equal to e to the power minus I theta minus right j theta minus divided by 2. So this is what we applied here. Okay. So then it becomes 2 of sine omega divided by omega. Okay. Now the second problem is set number C, that we want to use the definition of the P of T and modulation property to find the Fourier transform. Okay, in terms of P omega equal to Fourier transform of P of T. So we first see what is modulation property. Okay, so let's look at what the modulation property. Okay. Modulation property in our case is P of T if we have a signal. Now in that case, that is P of T in this case, if it is multiplied by cos phi t, okay, then you will have P of omega minus phi t. Okay, and how do we arrive at this thing? So it's very simple. That first you write the cos in terms of Euler. So P of T e to the power j by e divided by 2 plus e to the power minus j by t roof divided by 2. Okay. Um, Equal to P of T. Okay. So I wanted to write this. Basically, Laplace transform. Okay. So P of T e to the power j by t divided by 2 plus P of T to the power minus j by, right? Okay. Now take the Laplace transform, but take the Laplace transform on the LHS side. So let's just call this whole thing is as LHS. F transform. So I'm just gonna write down LHS equal to 15 Now we will use a property. So you see that we already know that Laplace transform of P of t is your um, your P of s. And so in terms of the Fourier transform, you could write this as P of t equal to um, P of t P omega. Basically, you replace the S by omega because it with the S um, S equal to J omega we write, right? But since J is a constant, we don't write J in this case inside the function's argument. Okay, so um, so we can write like this. Now we can use the frequency shift property that if there is an exponential in the time domain that is multiplied by any function, that will cause frequency shift in the frequency domain. Okay, so since we have e to the power j, and you can use actually a table from the Laplace transform equation. Let me tell you, it's the table. Yeah, so table 3.1 from the textbook. What did it say? E to the power alpha t of t, okay, is f of s minus alpha. So we apply the same one. And so can see LHS equal to P of S e to the power, sorry, not e to the power, but you can say shift, right? So P of S, okay, minus pi j pi t. So j pi in this case, um, in the Laplace domain we write, and we are writing right now, right? J plus P S minus j pi. And so while writing the frequency, like while writing the Fourier transform notation, we just drop the j. Okay. So we write like this. We write like this. P of omega. Then now coming to the original functions that we had that we needed to write. We have x of t equal to 1 plus cos phi t u of t So we can write like this. This whole thing you can consider as P, P of t. That's what the question also told you. So, and then multiply. Okay, let me write down this first. So, 1 plus okay. Now this whole thing, um, this whole thing, the Fourier transform. So in this case, is we are considering this, right? Assumption. So taking the Fourier transform on both sides of x. So you omega plus we already determined from here. This is going to be the thing. Okay. Also, I forgot to write half. So we also needed to put half. Because, because we had a half here. Okay. So we will have this. So half of times. Okay. So that's what would be the final answer of this question. So I hope it is clear that how we did the apply the modulation property. First, we derived the modulation property. Basically, modulation property is that in this case that if you're multiplying a cosine with any signal, then you are basically getting the two components frequencies shifted in either direction, centered at the particular frequency. So in this case, it is centered at pi. Okay. Centered at. Okay. All right. So that was clear. In the meantime, it looks like my MATLAB function has finally executed. It looks like my system is really slow. No, it does not seem like that it was correct. So let's see what's going on in this case. Okay. So close all. T of x heavy side. Oh, yeah, I made a mistake here. That one of them should be +1. Okay, so maybe it should not take this much time, this long this time. Okay, yeah. So now we have something like this. If you adjust it to 1 so that we can see. Okay, so now, so this is what we have as a plot. Okay, so I hope this was clear. If you have any questions, then definitely feel free to ask.